When connecting the steelhead into your network, make sure you use the correct cable. A steelhead connected to a router or any other non-switch type device should be connected via a crossover cable. When connecting the steelhead into a switch or a hub, use a straight-through cable. And in this diagram, we see those same cabling rules again. Any non-switch device should be connected via a crossover cable to the steelhead. The steelhead should be connected with a straight-through cable to a switch or a hub. Pretty much every situation where people are reporting problems with a fail-to-wire functionality, it ends up being either an incorrect cable or mismatching speed settings. So make sure you use the appropriate cable when wiring up the steelhead to the network. When connecting to a LAN switch, obviously use a straight-through cable. When connecting to any other type of device, a host, meaning a firewall, router, another steelhead, etc., use a crossover cable. Also, don't mix the speed settings on the LAN side of the steelhead and the WAN side of the steelhead. Always strive to have those either be auto or hard set them to the same speed, so either 100 or 1000. You should be aware of how the fail-to-wire functionality differs in different Reels versions. Prior to version 5.0, anytime you would start or stop the service, restart it, reboot the box, or in case of a power failure, the hardware bypass relay would actually kick in, thus resulting in a quick link down, link up, and also the LAN and WAN ports would not show link in bypass mode. In version 5.0 and later, when you start, stop, or restart the service, we no longer kick in the hardware bypass relay. It's handled by the software. So even if you stop the service, you'd still see a link up on both the LAN and the WAN port, and you wouldn't see any loss of connectivity even if you just stop or started the service. However, in the case of an actual power failure, or if you're initiating a reboot, that hardware relay will kick in just as you would expect. So you would not see a link on the LAN or WAN port anymore. Certainly you would over on the switch side and on the router side. And in this case, you should expect a sub 1 second loss of connectivity as that relay is kicking in. When doing fail-to-wire and you experience a momentary loss of connectivity exceeding 45 seconds, you're possibly running into a spanning tree related problem. When a steelhead goes into fail-to-wire mode, there's a quick blip on the network that could trigger a recalculation of the spanning tree algorithm. During this time, the switch is going to block the port to make sure that there are no loops. In this case, either disable spanning tree on the port, or better yet, use the port fast functionality available on a Cisco Catalyst and also from other manufacturers. Quick note about fail-to-wire as it applies to the legacy desktop series, so the 100, 200, and 300. This would not apply to the current desktop series, the 250s and 550s. So because the legacy desktops only have 10100 NICs, you could run into a problem where the switch and the router in fail-to-wire mode aren't able to successfully auto-negotiate gig through the system. Again, this due to the 10100 NICs on board those systems. The workaround here, what we recommend is that you hard set the speed and duplex on the router and the switch side to 100 full, thus preventing any type of auto-negotiation failure. The steelhead's in-path interface could actually sit as part of an 802.1q trunk. When you do this, make sure you configure the in-path interface with the correct VLAN information. If you don't do this, you're going to find that the steelhead will pass all traffic across the VLAN trunk, but no optimization will occur. You'll also notice that you won't be able to ping the in-path interface. If the VLAN you want the steelhead to be in is the same as the native VLAN as defined on that trunk, no VLAN tag has to be configured on the steelhead in-path interface. Also, keep in mind, the initial jumpstart wizard routine is not going to ask you for the VLAN information, so you're going to have to go and manually configure it once you've completed the wizard. Sometimes you may run into a situation where everything seems to be configured correctly, but you find that no optimization is occurring. Troubleshooting this should typically start by verifying basic IP connectivity. Keep in mind that when you run a ping from the command line, unless you specify the source interface or IP address, that ping is going to go out the primary port. Use the -I flag in order to specify the source IP address of the in-path interface. Once you've determined that you have IP connectivity, move on to the next test, which is to verify port 7800 connectivity. By using the telnet command in the example on screen, you can verify that there are no firewalls or router ACLs blocking port 7800 between the two steelheads. If you run into a situation where traffic is optimized when initiated from one direction, but when initiated from the other direction, no optimization occurs, you're most likely looking at a problem where the LAN and WAN cables have been reversed at Site B. Either simply visually inspect the cabling or run the CLI command you see on the screen to see if you have more MAC addresses showing up on the LAN side than the WAN side. If you have a problem with the two steelheads detecting each other across the network, chances are pretty good you have a firewall somewhere in the network, or maybe something like a TCP proxy that you would see often in a satellite network, or maybe an IDS-IPS solution that is stripping out the TCP options field that the steelheads use in order to detect each other. A couple of options here. Obviously, you could go and change the configuration on the firewall or IDS-IPS and make sure that it does not strip out the TCP option 76 that's used by the steelhead. Or create a fixed target rule on the client-side steelhead that tells that steelhead where to send certain traffic. This obviously bypasses the auto-discovery functionality. A very large portion of the cases reported to our support group actually ends up being caused by a duplex mismatch somewhere in the network. Make sure you always match your speed and duplex settings when installing a steelhead. If the network is set to auto on the switch and the router, certainly leave the steelhead set to auto. If you have switch and router hard set to either 1,000 full or maybe 100 full, make sure you match those settings over on the steelhead. Try to make a habit out of always checking the interface statistics report from the GUI. Make sure you don't see any substantial amount of errors on any of the steelhead interfaces. If you do see some number of errors, also check on the LAN switch and the router side to see if you're seeing any errors there. So remember to check and double check that speed and duplex settings are matching across all interfaces. If you find that the steelhead interface stats look clean, but you're still suspecting a duplex issue, bear in mind that the problem could exist away from the steelhead. Use the ping flood command to ping one of the local servers and make sure that you're not seeing any excessive packet loss. Packet ricochet occurs when you have a layer 3 device on both the WAN and the LAN port. When you do the basic installation through the jumpstart routine, it only asks you for a default gateway, so you can get into a situation where traffic destined for the LAN is actually bounced off the WAN router. Now this will work, but it's not very efficient since the traffic has to travel through the steelhead twice. Avoid this problem by either adding static routes for each subnet or enabling simplified routing. SMB signing is something Microsoft developed in order to prevent man-in-the-middle attacks with their Windows file sharing. It is not encryption, but rather an integrity check or a hash that protects packets from being modified in transit. It's on by default only on a domain controller, so if you happen to have a file share that's on a domain controller and you're not seeing as good a speed increase as you would expect, you're most likely running into an SMB signing issue, and you should see log messages to that effect in the steelhead logs. So how do you know you're running into SMB signing issues? Well, most commonly, you see this when you're copying a file and you see great data reduction rates, but the absolute time it takes to transfer the file is still not as low as you would usually expect for that file size. Also, whenever you suspect SMB signing, check the system logs. Look for the SMB shutdown error security signatures required messages. If that's present, you know for sure that you're seeing SMB signing. And that means that our layer 7 blade is backing off due to those security signatures. Also, if you look under the current connections page, any connection, CIFS connection with SMB signing on it would appear with a red triangle next to it, suggesting SMB signing once again. So where do you see SMB signing? Well, typically, if you have a file share that's actually residing on a domain controller, that's where you'll see that, because that SMB signing is forced on for any type of domain controller. Typically, a member server will not have SMB signing turned on by default unless you're in an environment that has certain security criteria where SMB signing is forced on every single domain member. So once you've determined that you're running into SMB signing, how do you work around that? How do you fix it? Well, the most obvious one, if you have a domain controller acting as a file share, move that file share and instead host it on a member server where SMB signing is not on. You could also go and change the setting so that you're no longer requiring SMB signing on that domain controller. There are articles up on the Microsoft knowledge base as well as some links on our knowledge base that will help you in doing that. You could also just live with a reduced performance where you're getting obviously good data reduction, but you're not going to get any of those application level latency enhancements from the blade. Better yet, better than all three of those other options, if you're running version 5.5 or later of Rios, simply enable the SMB signing feature. So in essence, you're going to join the server-side steelhead to the Windows domain, and by doing that, the steelheads can actually now sign the package just as a client, just as a server would in an SMB signing environment. Great competitive feature. Right now, no one else can do this in the marketplace, so we're unique to have this SMB signing support, and I should certainly suggest using it to your benefit. WCCP version 2, or Web Cache Communications Protocol, is a Cisco protocol that allows a switch or a router to redirect certain traffic to a steelhead appliance. Best practices here is to be connected directly to the switch or router on its own VLAN. Sometimes the CPU of the switch or router will spike when you enable WCCP. There are several things that you could try to help mitigate this. The basic one is to always make sure you use redirect in statements in the router switch config. Also, when possible, make sure that you connect via layer 2. If we're layer 3 connected, we'll have to use GRE as the return method, which is more CPU intensive for the router to process.